It is the average time between two successive collision between the atoms. So that is all about your relaxation time. In physics term, mobility means it is mobility of the electrons. Rho is nothing but the representation of resistivity. Electrons are getting drifted within the conductor, because of which there constitutes the electric current. Hello everyone, I am Vrunda, Faculty of Physics from Vidhyaashram Pre-University College, Mysuru, welcoming you all to Session 2, Chapter 3, Current Electricity. In today's class, let us just get into this chapter, that is by studying the drift velocity, mobility, as well as current and drift velocities relation, which is very much important, and current, resistivity and conductivities relations. So here, let us get into drift velocity. What is meant by a drift velocity? That means there is a drifting of electrons. Okay? There is a velocity, that is the movement of the electrons. Usually when the source is placed, which is attached to the conductor, when the source is on, what happens to the electrons? It keeps on moving. How does it move? In which direction it moves? It moves in the direction opposite to that of an electric field. Suppose if this is an electric field and this conductor is connected to a negative and this is positive. So the electric field is over this direction, which comes in turn like this, whereas your drift velocity will be in the other direction, which goes in this way. So electrons movement will be in this way. These are the electrons which moves in the other way. So how exactly you call it as drift? Once when the energy is gained by the electrons and it starts moving, it moves up till certain distance and then hits the neighboring electrons. Okay, it hits the obstacle, that is the neighboring electrons, and finally it regains its energy and gets accelerated further. That is, there is a passing of energies within the electrons, because of which they are said to be drifted. So this is called as the drift velocity. So the average velocity with which free electron gets drifted towards the end of the, that is the positive end of the conductor, under the influence of the external electric field. Only if there is presence of external electric field, the electrons are said to be drifted, or else the electrons acts as a free electrons. So that is known as the drift velocity. For example, you know that you have got force is equal to the charge which is carried, that is minus E into E vector, because minus E is the charge of the electron and E vector is the electric field. This is got by the equation on defining electric field, that is force per unit charge. So this charge which is responsible for the electric field is minus E, that is why we write it like this. Suppose if you consider Newton's second law of motion, which says that we have F is equal to ma. Suppose if the condition is like this, in the place of F, we do substitute m and a, which is equal to minus E and vector E. So you can retain it as acceleration and you can get your m to the denominator, where you have the presence of acceleration. Now you have, since these electrons are moving, there is certain equation which corresponds to this, the movement of the electrons, and that is nothing but equation of motion, which has got final velocity. Initial velocity is the sum of acceleration into time. That is, v is equal to u plus at we have got. So continuing with the same thing, just consider your v as it is and u is the initial time. So the average velocity of the electron during initial case is said to be 0, plus substitute for your acceleration minus E vector E by m into t. So you have this equation. So what happens to your velocity? That is the final velocity which is gained. That is called as drift velocity. So let us write it here. So you have got your velocity which is equal to, since the average velocity is 0, I'll just discard that and write only minus E vector E divided by M, and you have got your time called as T. And remember, when there is movement of electrons from one end to the other end, there is a collision between the neighboring electrons. And that collision between here one electron is present, here one electron is present. But this area is which is free of the neighboring electrons, so that no collision occurs. That time is called the relaxing time of the electron. So that relaxing time is said to be a relaxation time, which is given by tau. Okay, it's a symbol of torque. Okay, so what is relaxation time? Relaxation time is nothing but it is the average time between two successive collision between the atoms. So that is all about your relaxation time. So this time T can be written as tau. Okay, so you have got your velocity wherein your electrons have got drifted, called as drift velocity, and this can be relaxation time, and write your acceleration value same as it is. So what is the equation we have got? Drift velocity is nothing but this equation, minus E vector E divided by M into tau. So what does this equation conclude? It concludes that the negative sign is due to the movement of the electrons opposite to that of the electric field. Movement of the electron is that is opposite to that of the electric field. So electric field is opposite and movement of electron is opposite, because of which there exists a term called as current, which is represented in terms of ampere. Okay, so this is all about your drift velocity. So I hope you're clear what exactly is drift velocity and how do you define the relaxation time. That is nothing but the relaxing of the electron or the atom, the relaxation time of an atom to be defined, and it is given in terms of tau. V subscript D is nothing but the drift velocity. Coming to the next concept called as mobility. So what is meant by mobility? Mobility means mobile. Okay, it's like moving. Okay, so here, since you have got your mobile phones, how did the mobile term exist? That is due to wherever you go, you can carry it, correct? So that is why it is called as mobile, cell phones, okay? Similar way here you have got your mobility. Mobility means the movement of the electrons. You might get confused. Why did I get this image over here? That is not just in order to show you the movement. Any movement is known as mobility in general. In physics term, mobility means it is mobility of the electrons. Okay. So here, mobility means the magnitude of drift velocity per unit electric field. For each unit of electric field, what is the movement of the electrons? That is the drifting of the electrons. That is why we calculate the magnitude of drift velocity of the electrons per unit electric field is said to be mobility. So these are the 1 or 2 marks important questions for you. It comes for 1 mark, the definition. Introduce or define mobility. Definition of mobility means it is magnitude of drift velocity per unit electric field. So how do you represent this mobility? It is represented by this symbol, which is equal to magnitude of drift velocity per unit electric field is said to be your mobility. So what is the SI unit of this mobility? So SI unit is given by M square V inverse S inverse is said to be the SI unit of mobility. Coming to the next concept. So let us just check what is our next concept. That is relation between current and drift velocity, which is very, very, very important, and it has got 2 marks question. It is the relationship between current and drift velocity. So now you will have to consider for this a conductor which is having a length L through which a electric field is said to be flowing. And the movement of the electrons is towards the other side, that is the opposite side, okay? And this conductor is said to be connected to a source. Without connecting to the source, you'll never be getting the electric field. So this is the conductor which is connected externally to a source who is having a length L through which electric field is flowing in direction opposite to that of the flow of electrons. So how do you calculate the electric field? Electric field E is equal to the potential which is given per unit length of a wire or a conductor. E is equal to V divided by L. So in the direction of the electric field opposite to that, the electrons get drifted. With what? With certain velocity. And which velocity is that? How do you represent the drift velocity? It is by V subscript D. So there is a movement. We are starting up now by taking electrons into our mind. So now electrons are moving in general. So it is getting drifted with a drift velocity. So we have Vd. So drift velocity of electrons is given by V subscript D. How is it getting drifted? At what interval of time it is getting drifted? That is a change in time. The change in time can be called as delta T. So it is drift velocity of electrons Vd at time interval delta T. So we have Vd in and delta T. Therefore, we have the equation Vd into delta T, wherein the overall representation of this conductor is nothing but in order to equate it for a charge Q. Okay, because there is change in charge which leads to the current. As the current changes with certain interval of time, what happens there in that setup? There is a generation of current. So here for the generation of current, what are the internal things which is happening? I am writing it now. So we are equating delta Q is equal to V into delta T. Delta Q should be the fixed quantity wherein because of which we will have a current. Okay, so now we have got delta Q. Vd is the drift velocity at certain interval of time, call it as delta T. And when it is a very big conductor or conductor of any length or any dimensions, in order to check how much is the electron which is getting drifted, we will magnify the image of the conductor and just take a part of it. That is, we consider only certain area of it in order to check the drift velocity of the electrons as well as time. For that case, I will have to change this equation as I have to introduce area to this. So therefore, my equation turns out to be delta Q is equal to, if this is the velocity which is getting drifted in certain interval of time in certain area, call it as A into Vd into delta T. And in this area, there is n number of flow of electrons. So call it as, we don't know what is the number. So I will just take n as the number, that is the variable. N into A into Vd into delta T. And what is that n? N number of which charges? That is the electrons. So I have delta Q is equal to the electrons which is having the sign that is negative N, A, V, D and delta T. So this is the number of charges, that is the electron which is moving in the opposite direction to that of the electric field, just in order to relate with the drift velocity as well as current. So we are very near to relate it because we have already have the drift velocity and we have something which connects the current. Okay, so now what is the current? Current, how do you produce current? Current is nothing but rate of change of charge with respect to time, correct? So I can just write this as delta Q divided by delta T with change in time. So can I represent this delta Q as I into delta T? Yes, I can. So I'll just substitute as delta Q can be written as I into delta T, which is equal to E N A V D into delta T. Okay, here this was a electron's charge which I had given where it cancels out in a magnitude condition. So here there is not necessary that you will have to carry the negative sign over again, and now here delta T and delta T gets cancelled, so you have I is equal to E N A V D. Okay, so this is the equation which connects the current and drift velocity, the one which gives the relationship between current and drift velocity. So you have it, the final equation. I means it is current, VD means it is drift velocity, where A means area, E means electron, and N means number of electrons which is crossing over that area. So this is a very important derivation for you, which will be asked in the examination and which consists of 2 marks. Okay. So coming to the next topic, it is current density, resistivity and conductivity. We are relating all three together. So how do you give that? We have the current relation given as I is equal to NEAVD. That is a previous equation. And we also have the drift velocity given as, which is equal to E divided by M into tau. Now, apply in equation 1 for VD. So we have I is equal to NEA into capital E divided by M into tau, which on equating you get N into E square A E tau by M, which is current. So this equation, call it as equation 2. And we know that we have studied regarding current density. Current density is represented by, we have current density represented by J vector. So here, first one we are dealing with now. So current density is nothing but vector J is equal to I divided by A, current per unit area. So I will have to substitute this equation 2, that is for the current in the place of I. So N E square A E tau by M into this A. So A cancels with A. So what am I left with? It is N E square E tau divided by M. So this is the equation now. Having this equation, we also know that magnitude of current density, it is given by conductivity into electric field magnitude, which can be equated as, in the place of J, I can substitute for this equation. So I have, which is equal to N E square E tau by M. E cancels with E, so I left out with N E square tau by M. So this equation is nothing but the one which represents the conductivity. So here your conductivity is also done. What are we left with? Resistivity. Students, resistivity is the reciprocal of the conductivity. Reciprocal in the sense 1 divided by rho. Okay, that is, rho is nothing but the representation of resistivity. So conductivity is the reciprocal of resistivity. So since we have resistivity is inverse of conductivity, we can write this as resistivity is equal to inverse of this equation. All denominators will go to numerators, all numerators will come back to denominators. So it will be m divided by n e square and tau, which is said to be the relation between the current density, resistivity and conductivity shown with the help of these set of equation, where we are playing the game with current, drift velocity, current density, conductivity and resistivity. And the game is very tricky and very easy also if you learn it. Okay. Next, coming to deducing Ohm's law. We know that Ohm's law is given as potential difference across the end of the conductor is directly proportional to the current through it. So when you just remove the proportionality constant, you get resistance R into I. And I get it. Correct? So what is this resistance? Resistance is written as potential V divided by I. Correct? And this resistance is said to be, with the help of the first law and second law of resistance R is directly proportional to length and inversely proportional to the area. So what happens to this? It becomes like R is equal to, removing the proportionality constant, you get a resistivity into L divided by A. And we have to deduce this form. This was with the help of Ohm's law, directly we had taken this. But with the help of these set of equations which we have studied till now, that is with the help of drift velocity and current density, let us just get back our resistance value. That is the formula. That is deducing the Ohm's law. So consider we have the electric field which is moving in the conductor. Suppose if this is a conductor which is having length L and the electric field movement is shown in this direction, and the electrons which is moving in the other direction, it is having certain area A. Then the electric field which is passing through this conductor is said to be V divided by L. After this equation, it is our duty to consider the drift velocity. So, how do you consider the drift velocity? Why are we considering drift velocity? Because the electrons are getting drifted within the conductor, because of which there constitutes the electric current. So, the drift velocity is given by Vd, which is equal to E is the charge of the electrons and E is the electric field. I am considering the magnitude of it. That is why I am not considering any of the vector fields or else the signs, that is positive or it is negative in that way. Okay. Which is divided by m and multiplied with the tau. That is the relaxation time of the electrons between two successive collisions. So now we have in the place of E, can I substitute my equation 1? Yes, I can do it. So Vd is equal to E divided by m, and your V stays here, L comes down and your tau stays here itself. So you have got V and L in the place of E. Correct? Next, coming to considering the current I. What is I? We have NEAVD, that is the relation between current as well as the drift velocity. So here we have NEAVD equation which we had derived and which I had told it's very important. It's been asked very often. Okay. So here we have got, which is equal to, in the place of this VD, I'll have to substitute my equation 2. So here I is equal to, substituting equation 2 in I, you have NEA, what is VD? It is EV tau divided by M into L. So you have got the equation I is equal to NE square AV tau divided by M into L. So this is said to be the equation which can be rewritten as NE square A tau divided by M into L, and the whole set of equation is put inside and V is put outside, with I is equal to this equation into V. you will have to interchange the whole set of equation because we have V by I is equal to R. V by I. I need to get to this form because I have V, I have I, okay, I need to get R. So, one side is already known, that is V and I. I can directly put R in the unknown place. So, let me just consider your ML goes to the other side, that is ML goes towards here, and your NE square A tau comes here. So, ML divided by NE square tau into A, which is equal to your V stays there and I comes down, so divided by I. Retain your L and A, and V and I is nothing but L by A, which is equal to V by I is what? R. V by I is what? R. So what to do with this set of equation? It is considered as the constant term, and the constant is nothing but proportionality constant, which we have used here called as rho. So you have rho into L by A is equal to R. What was our question? In order to deduce Ohm's law. Deducing Ohm's law in the sense, with the help of the statement, we have deduced it to a form of R is equal to rho into L by A, which is said to be the last equation, and here ends your equation. This is also one of the most important derivation in order to deduce Ohm's law. Clear? So they might ask statement of the Ohm's law and deduce the Ohm's law as well. Okay. So this is all the things that is very important in this master chapter, which consists of 13 marks. So it's very easy, very easier if you just know the expressions. If you know the expressions, it's very easy for you to crack the whole chapter, that is current electricity. So in today's class, we have done the drift velocity, mobility, relation between the drift velocity and the current, and having the current density. We have checked for conductivity and resistivity, and we have deduced Ohm's law. So these many things are just a part of the chapter 3, that is current electricity. Let us all meet in the upcoming classes with the upcoming sessions of the same chapter. Until then, have a good day. Thank you.